way he describes moving the column is not the way I've done it traditionally, but see how to basically move the column over. In fact, I don't think his description is very good. He says to, so that's what I did the first time, and then it ended up filling to the right. You're going to move it over to column H. Yeah, move it over here to empty column, to H. And that's what I did a couple times while I did it. And go ahead and do it. You can always undo it. Right, so then go ahead and do it. See, I screwed it up. So just undo. I did this like 4 times. So I don't think his description's very good. You got to get it to that little arrow up and down. More like that, yeah. Not that, that. Wait, not that. I think a little bit left a little bit.
Like a little hand.
Is it there? That thing. That thing is the arrows. It's the cross with the arrows at the end. So down a little bit. Oh, look, maybe with your Mac. What was it with the Mac? Oh, you got a hand. Adam doesn't have a hand.
So then you still want the piece.
You're up too high though. Go down a little bit.
So then you just want. Oh, I got you. I got you. You want the piece to next. Okay.
There, maybe. Although Keat had a hand, but it's weird. I'm going to show you how I did it. I just wanted you guys to struggle like I did. Did you get it to do it the way he said it, John?
Yeah, but
I just wanted you to feel my pain. Because I did the same thing. I filled it to the right like 5 times. I'm like, because I don't think his description's right. But
It's really
here's how I would have done it. I would have just taken this column and cut it. Control X. And I would have moved it over to column H. And Control V. And then I might have even deleted this column. If you just delete this column, it'll suck them all the other way and you're done. That's how I would have done it. And I think the little dragging and dropping might have its advantages in some cases, but that worked a lot slicker for me. So however you do it, get C and D together, and then you're ready to run your regression. So when you're on the main page here, go to your data analysis and run your regression.
So what are we inputting and where?
So you've got the quantity of slices is your
Y, right?
is your Y, your dependent variable. But now you're going to grab onto both of these two, and that's why you need them next to each other, because the way Excel takes them in, you have to grab them together.
And you have labels on residuals.
Oh, you did the X first? Okay, yeah, do it that way.
And it is in your independent variable.
You know, there's a little bit shorter way. Okay, wait, you didn't do your, you gotta go C to D. So in your input range now, go ahead and just go over there. Instead of, you press that button, that's what you did, right? Don't press that button, just go right over there.
Oh, I didn't.
Go on to C, or scroll up so you got the label. Grab onto P slice, and then as you're highlighting, grab all the way over to the D column too. There you go. And now when you're done, see it inserted it automatically? You're done. See how it's C to D?
Oh, okay. Is that right?
And then if you want, you can do the,
independent both.
you don't have to do the, I don't think we're asking for the residuals on that, but the labels for sure. Yep. And then you just hit OK and you're done. It's going to create a new sheet. Did you get it, John?
Yep.
Do we want residual?
You can if you want. I don't think we're really asking for it on this one. So. There you go. And so now you can check your work to make sure you got the right answer from our 2A. It should match up. I'm going to go ahead and do it. Taylor, I don't know if you saw. I'll go ahead and do mine. So data analysis, regression, okay, input range. Looks like I did this one already. B. And then let me just redo this one. grab up on the P slice, drag over to both columns. If there was 5 variables, you'd grab all 5 and do the same thing. So grab that, hit your labels. It's like I had all these things turned on.
Okay.
And run your regression. And so notice it creates a new sheet down here, and it should look like 2A. Everybody good? All right. Now let's get a little crazy. Did I hear everybody? Everybody's good? Adam, did you get yours going? Okay. 2B. Check this sucker out. I love this. This guy's crazy, man. I don't know how he did this, but I tell you what, this would have helped me with my econometrics class if I would have had this originally. Do you guys dig this? Do you see what's going on immediately? It takes a while to digest. Chelsea, you've done a little bit of this in calculus, maybe?
We had equation of planes.
You had what?
Equations of planes.
You did? On your test this morning, even? Oh, really? So I see that little sadness in your face. Okay.
No, I mean I understood that one, so I was like,
All right. So, so what he's trying to do is just give you an intuitive feeling to it. So go ahead and read this part on the diagonal. Just kind of read it to yourself, and then we'll pick off some of the things here. And then start looking at the axes. So, oh, did I forget my markers? Oh, I might need to fix that after I get you guys going. All right, so this 3-dimensional thing is our scatter plot with a linear regression, right? Same thing, we got slope-intercept form, except now it's this 3-dimensional creature where we've got the price of the slice is running here along this axis, and then the price of the soft drink is here, and the vertical axis is the quantity of slices. You guys remember from principles class, maybe, Colby, you didn't have me for principles, did you? One of my favorite talks in principles class was thinking of the room being the 3-dimensional thing, and that the corner of the room here is the dependent variable, the quantity of slices, and then running along this wall where this plane, where these two meet each other, is the price of soft drinks, and the price of the slice is running this way. Yeah, maybe I did in other classes where we got, I think I did the production function where it's coming up over the room and we take the vertical slice and all that kind of stuff. So you can kind of imagine this picture being on there now, where we've got the quantity of slices on that axis, and the coefficients over here tell us what this plane looks like. So it's kind of this plane, rectangular, square plane, rectangular plane. I guess I don't know whether it would be a perfect square or not. Maybe you guys know. I can't think off the top of my head.
plane is not.
So the intercept is still the same concept. So 26 slices. If the price of a slice was 0, if pizza was free, then people would be eating 26 of them, is the interpretation. Where does he say, that wasn't part of this? Did he say that up here? Yeah. Y-intercept, the average student, if it was free, would be consuming 26.7, so that's this point. And then we've got the slope of 8 and 7. So running along the wall here shows us that 2-dimensional creature. And running along this wall is this part of the plane. And so we've got that going here, which follows our slope rule. And so coming down from point B to point C, we're following the slope of the pizza slice, or that was the soft drink. And so he shows the rate of change here on the slope being down. This is kind of a rise over run thing here with the slope interpretation. Okay, did you guys read the rest of this? Okay, let's read the rest. Any questions on that? I guess let me jump to point D, because that's what he does here. So if we fix the price at $1.50 and the price of a soft drink at $1, we end up at point D in the middle of the room, right? So point D is out in the middle, and at point D, the height is our, what is it, 7.5 slices. So if we take that D that might be John's head, sitting out in the middle of the room, we take his head and we project it back to the y-axis, it's 7.5. Starting to see it? The thing that we're trying to get an idea of is that these equations and everything map back to that simple linear regression where we've just got a scatter plot. Hopefully we got the intuition of that. We're fitting a line that's the best fit using the sum of least squares to fit the statistical average of the best fit of the relationship between the independent variable and the dependent variable. We're doing the same thing in three-dimensional space, except now we're trying to fit this plane into the data points. So imagine that there's a scatter plot of points like John's head and Kate's head and your head. All of your heads are points out in the room that are suspended. Those are our data points. And now what we're doing is we're taking this plane and we're statistically finding the sum of least squares through the points in the room in this three-dimensional space, using the same properties that we did with the two-dimensional space. Okay. Okay, I'll make sure I got all that. Screen. So read the rest of this down at the bottom. Okay, so the one thing I wanted to point out, if you didn't catch it on here, where that 7 came from, if you put your cursor over the 7.25, he's got that calculated, and then go ahead and double click it. So this is the answer to the equation he's got below. Again, if you double click it, just like we've been doing, then we've got the equation highlights up and it's colorized, and it tells you that it's grabbing onto the points. We've chosen these data points at $1.50 and $1, right? And then we're just plugging it into that equation.
And it's not the one that's up top.
Yes, he's mapping this out.
Well, I mean, it has the equation.
Oh yes, right. It's this one. Yep. Which they've got restated right here. That's the actual equation, but it's helpful to double click it and actually see where it's pulling the data. So again, it's pulling the slope of the price times the price, and the slope of the soft drink times the level that we're picking. And so we're picking out this point D out in three-dimensional space. We're saying, hypothetically speaking, what if price was $1, price was $1.50? How many slices would we sell? And what that allows us to do, that we'll also do in a different one, is what if soft drinks were $1.50? Now, what would you predict would happen? Oops, I gotta go 150. What if the price of a slice and the price of soft drink was $1.50? go up or down? How many in terms of slices sold? Because the two goods are complements, and you know that because of the direction of the coefficient, the sign of the coefficient, right? So a negative sign on the price of soft drinks. If the price of soft drinks go up, the quantity sold goes down. It's a negative sign, right? So we're back to our principles of Econ 101, complements and substitutes, that would be a negative sign. So that's where the intuition is coming from. So if you do that, they drop to 3.96. So that would be our prediction. If soft drinks go up to $1.50, then we're going to lose pizza sales to the tune of 3.5 change in quantity. Then, of course, from a business standpoint, am I making 50 cents more in soft drinks enough to offset the 3.5 pizza loss on the pizza side, which gets us into a different world, right, of calculating profit maximization and elasticities. All right? Comments or questions? Ready to leave this creature? All right. Check this one out. So this is 2C. Taylor, are you okay with that? Let me see your face here for a second. There we go. Okay, thumbs up. Good. Maybe I'll keep you live up there. I think I can do that. Okay, so this worksheet has 4 main goals. T statistics, which should help you for your homework, to learn mistake-free estimation method, to understand confidence intervals, and to understand the difference between the magnitude and significance. So start with number 1 on your own and just read through. He has you click some cells to see, but start reading number 1, and then I'll kind of open it up for questions, since that's the one that maybe a couple people had some stuff on from the homework, especially. I'm going to go actually get my markers. Questions on the T-stat one?
What's the saying here on the confidence interval? Confidence interval is BG plus, I get the rest of it, but BG.
You're on number 3?
Yeah.
I'm going to go in order first. So let me just stick to number to number 1, the T-stats. Did you get what he did here? Because that's kind of what you had to do for your homework. Kate, that's no. You guys, please speak up. So check this out. Over here, he created the variable themselves. So if we take tuition and double click it, he set this up as a formula to show that he got the same answer by grabbing onto these 2 cells. He got this answer. And that comes to us from what you needed to do for your homework with the calculation of the t-statistic. I'm sorry, we've got the estimated coefficient divided by what? The standard error of the coefficient. So remember that there's this standard error too, which is the standard error associated with the overall regression. And each individual statistic also has its own standard error. So the standard error of the coefficient. So B hat, remember when we have the hat on top, it's the estimated value of that coefficient. And that is our t-stat. And then that sets us up to do the t-test. So what he did here is he just wanted to show that you can do the algebra any way and solve for any one of them. If you know 2 of them, you know the other one. That's all he was saying. And so he just did the calculation. When this one was generated, the computer just magically put it up there, right? And so we don't necessarily know that that's the way it works. That comes from our textbook and our underlying theory. And so he just used Excel to just prove that indeed that is the way it works. That's all this was. Okay, questions on t-stats. Let's spend some time on this. What do you get? What don't you get? I'm willing to start from the very beginning.
I guess being able to tell whether or not you need to go 1 tail or 2 tail.
Okay. So that brings us to the topic of hypothesis testing, which I don't think this book does a really good job of. But it does it in bits and pieces, but on a revision, I think they could be a little cleaner on it. On page, I don't know if you guys brought your books, but I can, you don't have to pull them out. I just thought if you had them. I want to find the section where they did bring up hypothesis. Here, page 121, I guess on the domestic version of the textbook. So we come into the regression thinking, I think that the price of a slice is an important determinant to the quantity of slices. And somebody says, BS, that's not true. Who cares about price? It's all about income, right? See where I'm going with this is that we're going to use our statistics to test that hypothesis. The null, or the standard the way we set up hypothesis testing is we say that it is equal to 0, that price does not matter. So the null hypothesis that we're trying to overturn, which again, this textbook doesn't really use this, but the null hypothesis is that beta hat equals 0. And it's really that the true underlying beta of p slice equals 0. However, the alternative hypothesis is that b slice is going to be something less than 0, i.e. the 1 tail, 2 tails, where I'm going with this, by the way. So we've got, that is our hypothesis test that we're really carrying out through running this program. So we run it into the computer, and the computer cranks out negative 0.09 as the coefficient. And you're like, woohoo, I told you price mattered, right? But then we're going to check to see if that estimate, B hat, is significantly different from 0. In other words, 0.09, well, that's kind of small, Russ. What do you mean 0.09? That's like nothing. Well, is it truly like nothing is kind of what we're testing. And so we're going to do that by looking at the standard error of the coefficient, how spread it is. It kind of is related to like standard deviations away from the mean. Is it possible that 0 is still the answer, but it comes out with this point estimate of 0.09? So using the standard error, we determined that the t-statistic is 7.82. All right, so that's just a statistic that tells us how tight the relationship is. If we're thinking, for me, my brain, I don't even know if this is totally statistically appropriate, but if we're thinking about 0.09 being here, does the bell curve look like this, where 0 is here and maybe whatever, 2's over here or something? So it's likely that that's no good. It could be 0, it could even be negative, it's kind of, that this gets us back to kind of the confidence intervals. Or does the distribution around it look like this, where we can be reasonably confident that it is indeed greater than 0? And I'm using greater even though we got negative sign here, so forgive me. Is everybody with me on that concept? Slow me down if it... Colby? Yay? Nay? Did I lose you? Adam's giving me a shake, iffy 50-50.
First question, do you have to get your coefficient from running the regression analysis?
Yes. So the coefficient is that hyperplane, or if we go back to simple linear regression, it's the slope of this thing, right? So here's our regression line. And the regression line is quantity of slices and price of slice. And we've got quantity is equal to my intercept term plus my slope term times the price of the slice, right? And we've now estimated this beta coefficient through regression to be 0.09. Does that help clarify that? So yes, the computer cranked out this coefficient. The computer also is telling us how much variability there is with that through the standard error of the coefficient, how much wiggle room there is. Like, is that kind of a BS figure, or is it pretty tight? And that's what I was trying to illustrate here. Is there a lot of wiggle room, or is it a pretty tight estimate? In other words, that hyperplane fits in there really nice and snug, right? There's not a lot of wiggle room. It's not doing this. It fits in there really nice and tight. That's somewhat what the, conceptually in my brain anyway, what the standard error of the coefficient is measuring. And then together we use those to create this t-statistic. And that is the 7.8. Statisticians tell us, and it's through probability theory, that we have these little tables, which is the critical value of the t-distribution. So on page 575 of your text, if you don't have your text, it's not huge that you pull it out here, but on 575, you get the list of all t-statistics. And depending on the number of observations you have and the number of independent variables determines the degrees of freedom. That's what the degrees of freedom are. What did we learn in kind of statistics 101? Big sample is better than a small sample, or vice versa? Big sample's good, right? So as the sample size gets bigger, look what happens to the numbers of the critical t-values. Are they going up or down? They're going down, which makes it easier for this number to pass the test, right? This number has nothing to do with this table. This number was a statistical artifact of the regression and what we did. And so we're saying for this particular set of data, that coefficient has a t-stat of 7.8. What does that tell us? Well, the statisticians tell us that if you had 30 observations, or whatever the degrees of freedom ended up being here, what was it? It's somewhere on here.
It was 30 observations.
Here we go, 24. Yeah, so we had 5 variables. Well, and you include you throw the intercept in as the 1, but 1, 2, 3, 4, 5, minus 1, 30 minus 6 equals 24. So we had 24 degrees of freedom. We run across and we find out that 7.8 is huge compared to what we had to get to claim a 95% confidence that it is away from 0. And that's all we're trying to do is make that bold claim that we feel pretty confident that this number is a good one. All right. The floor is open again. What else?
In the homework, it was asking us, it would give us a command function with all of the little variables.
Mhm.
How are we even supposed to start going about putting that into the regression?
Okay, good question. Well, let's see. I'm not sure if you're talking about. It's still a good question, regardless. But in my mind, I was thinking you were talking about.
Yeah, so if
Yeah,
we don't
those
have
little
to
things
do
in
that,
parentheses were in there.
Yeah, if,
Yep.
then what is that next step if we don't have to put it into regression? Because I was actually taking those, it's just like.
So, Kate, then you're back to doing this. You're back to manually creating it.
Just manually.
Because you've got, so I've got, I think this is what you're talking about, right? This equation at the bottom?
Yeah.
Okay. So this is kind of the standard way that economists show what the regression spit out. Excel spits it out this way. Different statistical programs will spit it out different ways. So when we publish papers, when you guys look to your journal research, you'll see this as kind of a common thing, one way to express the equation. Other times it'll be shown in tables too, so you'll also see that. But in this equation form then, we've got Q equals 15,000. 15,000 was the intercept, and it had a standard error, the coefficient of 5,234. For this problem, we had an intercept of 29.1 and a standard error, the coefficient of 2.2. Now they didn't show this, so that's what your homework problem's asking for. And now you need to go back and take the estimate, which is the number in the equation, divided by the standard error, the coefficient, which is the number in parentheses below it. Okay? And again, that was kind of buried in the text. Again, I don't think this is stuff that's easy to read and say, oh yeah, I got it, and then you go to the problem and it's like, well, what are these little parentheses?
It's like they say you do this, and then here's your answer. They don't actually show you what they did. They say the standard coefficient is this, and so this is your answer. But
Yeah.
I'm not going to show you how they actually got that.
Right. And as I've gone back, I think at first I thought it's not there, and then I go back and I'm like, oh, I guess they did kind of say it. So as this starts to sink in, it's really layered with a lot of detail. They did have the t-stat and the t-value on page 122 is that formula, which is the one you would have needed to do that problem.
I guess it would have helped if I knew.
Yeah. Yep. I agree. They weren't real clear on that. So that's that part. And then it's pretty much just doing, the division and calculate the t statistic. Let's talk about the rule of 2. What did you get out of that? What did that mean?
If it's over 2.0, then t-stat's going to hold up in
Yeah.
1 or 2 tails.
So you're basically golden if your t-stat comes up over 2, which, like, eyeballing this, 29 divided by 2 is 13. 13 is way bigger than 2. That's, that's fine. That's significant. Which, by the way, significant intercepts sometimes might be a sign of you've got some missing information sometimes. So back to this again. Those of you who have it, page 575. This was our table of numbers again. Along the bottom, we've got degrees of freedom going from 1 to 200. And if you look at the 5%, even the 5% two-tail test, which is the third column of numbers over. But notice it says two-tail, one-tail at the top. Go to the two-tail, 0.05. So that's a 5% test. So we're going to be 95% confident that we can reject the null. If you look at those numbers, as long as you've got a sample size that is, greater than 20 degrees of freedom of 20 or so, you start to see that we get to 2.0 pretty quick. 2.093, right in the middle of the page. So if you have a data set with 200 observations or whatever, 2 is going to work for sure, even on a two-tail test. On a one-tail test, it gets easier. And this is a one-tail test here. We just want to, the price should be negative. And so we're going to make sure that we've got enough room on the one tail, which means we only had to be above, 1.7. We had a 7.8. So we're good. We're 95% confident. Now, furthermore, we're good. How you'd publish this in a paper is you'd probably say, we're confident at the 1%, we're 99% confident. So sometimes they'll do this with asterisk, but on the far right at 24, if you've got a t-value of 2.5, you can be 99% confident that things are looking good for yourself. Okay? So it's our confidence level that we have in the statistic. And what we're, some of the language that you'll see in these spreadsheets is that we're not accepting the alternative. We're not saying that this is gospel, that this is true, but we're rejecting the null. We're saying, I'm 95% sure that this is not the case. I'm 99% sure that this is not the case. In other words, we don't leave out that little, economists like a little bit of wiggle room to say, oh, well, I guess there was that 1% chance without screwing up. So that's just the way the statistics work, right? I mean, it's about as sure as you can get in probability when we get up to 99. Okay, other questions? T-stats are a big deal, so this is one I wanted to spend a little more time nursing. Taylor, good? Thumbs up. You've had some of this in your previous courses, haven't you? Yeah. So when we talk about is this good a normal good or an inferior good? Income goes up, do I buy less pizza or more pizza? Is income a normal good or an inferior good? How do we decide that? It's based off the sign, which means it could be greater than 0 or less than 0. Two-tail test. Right? So that's the idea of anchoring, whether it's two-tail or one-tail.
What if you were rejecting, or if you were, like, say, your hypothesis was that it was an inferior good?
Right.
Then that would be a one-tail.
Yeah. Yep.
But if you're saying income, that it had no effect, and then you're just looking at if it does have an effect, like inferior or not.
Yes.
Then that would be.
Yeah. We can do the same thing with complements and substitutes, because the sign would be either positive or negative. Okay, so what else do we got here? So what was number 2? The other ones will go a little bit quicker here. So anything else on last things on T-stat? Want that one nailed down. Super important. You're going to see that in your journal articles on what was significant when it went. That's the one thing. And then you'll start to give interpretations. If the price of soft drink is increased by 10 cents, then this is the marginal effect, right? So if, in economics class, we're all about decisions at the margin. This slope coefficient, that is at the margin. It's like if you do a small incremental change in that variable, it's going to lead to this change in the one we care about, the dependent variable, right? So that's all about looking at the margin for decision making. So that's why all of these are important. And then, of course, the t-stats are important to know if that is real, if that's meaningful or not. So of this, I guess as long as we're on this, what about this urban?
I have a question with dummy variables.
Okay,
Urban was
which relates to this one, yeah.
Yeah, the dummy and residential were
Yep.
dummy variables.
Yes.
So, I guess this is going off of like the t-stat part of it, but just when you do the regression of that, like how does that work? Like, I don't understand how it
So-
works since you only have the two, like it can only be 0.
Okay, so the data set has people in urban areas and people not in urban areas. If you're in an urban area, you get a 1. If you're not in an urban area, you get a 0. So all of the observations have 1s and 0s if we pull up. And I think this is good to look at the data
I
here.
think that was on 3s.
So here's the data.
So then when it kicks that all out.
Right, so with each data set, when it's processing the hyperplane or whatever, it's going to take that into account. And the fact that there is this kind of dispersion for this person who bought this much pizza at this price and this price of soft drinks, notice there's variation in all of these things, right? And then so for one particular data point, this person happened to be urban, that's just going to be processed right along in it. But it's now it's not a continuous variable, it's a 0, 1, it's a by.
And it still has a coefficient.
And it still has a coefficient,
Why
yep.
do some of those have both 0s and why do some of them have 1 and 1?
Oh no, because urban is whether the school is in the city or rural school.
Yeah, I see what you mean,
And then
John, here,
residential is
whether it
within
should
the-
be, oops.
Well, you would think that would almost be like binary. 0
No, because residential is just whether they're on campus or not. Not like what it is.
Yeah.
Okay, I didn't actually.
They're like two.
But a lot of times if it's male or female, there shouldn't be 2 1s in there. But for this particular case, there must be a blending of the 2 or something. Yeah.
It works, I just didn't actually read it. I kind of assumed.
Okay, so then back to your question here on the urban, it kicks out a coefficient. If it was significant, then the magnitude of the coefficient would be significant. We'd say 74% of urban dwellers, or they buy 0.74 more pizza than residential people do. Something like that would be the interpretation. But it's not significant, right? So rule of 2, 1.21 says that this is insignificant. In other words, you can't make that little determination that I just said that, oh, yes, it will. It causes them to eat 0.74 more pizza if they're an urban dweller. The statistics have told us there's way too much variation in that coefficient. It's way too much wiggle room to be that confident that 0.74 has any meaning whatsoever. It's absolutely insignificant if it doesn't pass the t-test. Yes?
But then from that data set, the influential thing would be the residential. That is significant.
Right. Yep. So for whatever reason, residential status did have an impact.
The tuition actually does.
And probably quite a bit of an impact here to the 3.
Tuition does actually pass the t-test momentarily.
Right. So yeah, this 1.73 probably gets you just above on the tables.
That was 2.0.
If that was a
The
one.
one that they give us on that.
I can't remember what the way they
It says
characterize
it on
that.
there.
You know, we've got another one that we're going to build off on that too. Okay, so number 2. Did you get what he did here? Did you guys read ahead or?
Oh yeah, that's at the 2 too.
Oh gosh.
So suppose you want to estimate a non-residential college man, and you've got some data that you're plugging in. So at $1, $1.50, we've already done this before, it was 7.5. one way to do it is what he did here. If you double click A27, he just created a formula and then put in the numbers. Now I don't know why residential wasn't picked up here. He's got urban. Must have been for urban. Is that why?
He said.
Oh, and it was 0 on that. Yeah. So an easier way to do it so that you can play some games potentially is to create this column of data where all he's done is broke apart the formula. So that's all he's trying to do in this number 2 is to say, again, the Excel stopped here, right, with the upper 95%. So he added 2 more columns and then put together he called them the pieces here of the puzzle, of the equation. And so B18 times H18 is just part of this equation. And that way, you can come back here and say, and do some situation analysis. What if tuition was $22,000? What would happen to pizza? Boom. And then we get a different number, 7.65. It changed right here is his number. So now, this one I didn't change. I'd still maintain the old numbers. Now I can kind of play little games over here and get the best guess estimate and see how it changes. Just a use of Excel to kind of show the intuition behind the point estimate.
That's kind of weird. That's saying that tuition goes up when you buy more.
You buy more pizza, and it's richer people. That's right. So we're going to talk. I don't think it's going to be today apparently, but well, maybe we will.
You're depressed.
About the multicollinearity. You remember reading about multicollinearity? So tuition and income tend to move together. So if we have an income variable and a tuition variable, that might start to move together. So that's what that's picking up.
So in other words, it's basically saying that it's a normal rate.
Yeah. Oh, you guys get bonus points.
Yes.
This is my wife calling me for at 10:30. All right, you guys can pass around the.
Very generous on this.
I guess, yeah. Getting sloppy, aren't you? All right, let's get over to confidence intervals. I think we really talked about number 4, but we'll look at that too. So, John, this is the one you were starting to have questions on. Why don't you give this a read first? So, read number 3. Okay, John, you had a question on this one?
Where did they get the 7.5 for 2023?
Okay, so 7 right here on D.
Yeah, which it said, oh, because it's their best guess. Oh, it's the best guess. Got it.
Right. That is our Q hat after plugging in the variables. That's our That's our 7.5 along the vertical axis. That's our predicted value. And then notice we're using the SEE, the standard error of the estimate, in B7. So if you go up to B7, that's this one that we haven't talked a lot about. It's up at the top of the screen. So B7 was 1.06. So for that estimate, that's where we put that one into play, because that's for the whole regression as a whole. And so we've got, we can use that number, and we can also do it for the standard error of the coefficients down here to get this plus or minus with the lower bound and the upper bound and our best guess. So the yellow formula here shows what they're doing. If we take the critical, the critical value of the t statistic, which we got from the 95% confidence interval, this was something that wasn't totally clear. That's coming from the table. That's called the critical value. You calculated the t statistic, and it was like 7.8 or whatever. But the critical value is what we're using here to create the 95% confidence interval, because the statisticians have told us that that follows the correct amount to be 95% confident that it's going to fall within that range. So if we take the critical value of the t times the standard error, and then do that plus or minus on each side, we can create these upper and lower bounds.
And the BG was the
Best guess, yeah. And the best guess is our,
quantity of that.
yes, our regression coefficient, our estimate that we came up with from our regression.
So how do you have, this is my question, how do you have a critical t value without knowing your confidence interval? Because they're saying you can solve for your confidence interval by having your critical t value, but find your critical t.
You can get the critical t from your degrees of freedom and going to the table.
But you still don't know what it is if you don't have confidence interval, because your confidence interval is
Oh,
That's going off of beta.
and then you're going off the standard error. So the standard error is pulled from your data.
okay. But it was standard error times the critical t value.
I think you go
Right.
with a certain level of alpha, just already.
Just a certain-
Yes. Yeah. And so from
Like
there,
if they
and
give you the alpha,
like basically like we did in stats. If they don't give it to you, you kind of find. I think then you find how close you can get on the alpha, like the smallest that you can make it.
So we get this kind of upper and lower going on here at the 95% level. That's part of the output that's given to us too. So we get that upper bound, lower bound is this last value of the data.
Yeah, if you want a 95% confidence, you just automatically get 5%.
And then we've got the point estimate. So I guess another way to think about it is we calculate the t statistic using the
Yeah.
point estimate and the standard error.
But that wasn't the t stat. You said that was the.
The t critical, right? So we're replacing that with the 95% level. Because this one's like 99. Our t stat's like better than that. So we're just restricting it to the 95% level only by plugging in the t critical. All right, super important here. I think we discussed this already. Understanding the difference between magnitude and significance. So questions on that. Magnitude is what this coefficient is, the actual quantity, the size of the coefficient. Significance goes back to the t-stat on how much wiggle room there is. If it's insignificant, it has no magnitude. It's one way to think about it. So in order for magnitude, in order for the coefficient to have meaning, it has to be significant. So significance is a necessary condition to gauge magnitude. You have to have significance for the size of the coefficient to matter. Otherwise, you need to believe in your heart that it is actually 0. The computer tells me it's 0.74, but it's really 0. I don't have enough data to convince me that that is anything different than 0. So don't count it as anything. If it's insignificant, it has no magnitude. It's 0. Okay? All right. So,
So we're still talking about the W variable.
yeah, let's see. I was going to actually flip back to multicollinearity, which I think we're at a good point to do this rather than waiting a week, and I got 5 minutes left. So,
Okay, so
we're doing
what?
that.
That's 11?
So this will at least get us started here. So this is 11, yes. Pull open Excel app 11. He's done 30 regressions for us.
Alrighty then.
It's a bit to digest at first, but it's now. Does your number 11 say with 3D, with revised with 3D? I don't think it does, right? Okay, that's fine. So I emailed the author early on, telling him that I was doing this course and I was kind of asking some questions, and he said, "Hey, check this out. I just came out with this. We're going to be revising it later." And so he's done this thing that, oh my gosh, kind of blew me away. But I think it's pretty cool. It brings us back to the 3D thing. So start with what you've got on the multicollinearity issue. So just to get us started, we've got Chardonnay and Cabernet Sauvignon and Merlot. The price of 3 wines is the data. So on your main tab,
This guy's way too fancy for us.
on your main tab, he did some, the story is he did some consulting for wine, and he got special permission from the people he did the research for. He was working for like Ernst & Gallo or something, but as long as he didn't use stuff specific to them, he let them use their data for the wine industry in general. So that he's pulling this from real world data. And so along the vertical axis here, we got 53 weeks worth of data. So first week, second week, third week, fourth week, all the way down. And these are the prices that were observed. So multicollinearity deals with things moving together. And so if we're trying to explain the price of Chardonnay, we might not be able to include both of those things in there because the results are going to get screwed up. So it's kind of similar to our tuition and income. You can't always put things that you'd think would be perfectly in there because they're moving together. And in order to get meaningful results for that hyperplane to fit in there nice and snug, you can't have things moving the same direction. So that's the problem we're trying to address with multicollinearity. And one of the things we can do early on is this ANOVA table to look at the correlation between the two statistics. And so look at, we got price of Chardonnay, price of Cab, price of Merlot, and then we've got the same thing being measured here, price of Chardonnay, price of Cab, price of Merlot. And then we've got the correlations between the two, and they're super high, right? So we got a 98% correlation, Merlot and Chardonnay. So he's intentionally leaving them, like this is not something we normally do, but just to show you what multicollinearity is, we're picking kind of an absurd observation. All right, so the next page has the regressions. And let's see, which one am I? set, and from S over is another set. So he's got 3 sets of regressions. And you can look at what he did. He ran the 2 here in the first column, and then just 1 in the second column, and then the other one in the other column. Right? So he ran them as independent regressions. As you scroll down, you can, he changed the regression output with the number of observations he was doing. So he changed over the 53 observations. He reran the numbers with different parts of the data. So here's our, I should have did this on the other page, but here's our observations. He said, let's run a regression on that chunk. Let's run a regression on that chunk. Let's run a regression on that chunk. So he picked off 20 different ones as we go. In theory, as long as the degrees of freedom are big enough, your coefficients should be relatively stable if you have a random draw of the 20 of the 53, then your coefficients should remain pretty stable. But look at what happens when you run both. What happens to the magnitude of the coefficients as he did it. So eyeball, as you run down the list here, we had 0.08 and 0.09. Look at what happens in the very next one. What happened? They flipped around. They flipped signs. The computer's all confused because those two things move together. It's kind of a coin flip. Is it a positive sign or is it a negative sign on fitting the data? And that's how things get screwed up with multicollinearity. So this is actually one way to test for multicollinearity, is to take a subset of your sample and run a few and see what happens to the magnitudes. And you can see they jump around quite a bit as you scroll down the list. Whereas on the independent ones, the coefficients remain pretty stable. If you look down the list of just the price of Chardonnay or the price of cab, you got 0.73, 0.73, 0.73, 0.74. So as you eyeball the list going down, those coefficients remain pretty stable, which is what we'd expect when we don't have multicollinearity. And then this last tab, he just kind of shows how they're moving together. I got to show you this. I know we're basically more than out of time, but this is the one that you guys don't have. This thing is unreal. So he took this, all of these runs of the regression, and he plotted them in that 3-dimensional space. These are the hyperplanes with that. And then he set up this little slider to look at different views. See how that changed? So we're taking the model and we're able to slide it around and look at the data. And he's got these little push buttons here so that we can click on and off different parts of it, and you can see them flicker. There's the data points, and then this is the trace data in the PC plane. So anyway, there's more to look at here, but I just thought this was kind of cool. And then as you unclick this, you can start to see, take away some of the regressions on how the planes are just cycling along that axis. So the hyperplane is just doing this along the collinear prices that are all the same. The hyperplane is just doing this. Pretty wild. All right, this guy's got more time on his hands than I know how long it takes to build some of these things because I've done them. This is way out there. This is pretty cool. Okay. So why don't I'll send out an email as far as things to be doing this week. One of them is to hit the Chardonnay. The reason I kind of wanted to tee you up is at the end of the chapter, there's an appendix on the demand for white zin in Los Angeles. And that's where this data set was pulled from the appendix. I'll send you out an email on the details, but there's text to read, and then we're going to end up going through another model that shows that.
So we're staying in this chapter.
Yes, we're staying in this chapter. Yeah, oh yeah, we got more to go.
Still not doing all that.
We aren't even close yet. Yes, so we'll spend a little bit of time. Good job, you guys made it. Is it starting to sink in a little bit more of what's going on, or are we still in the foggy zone? I tell you what, I've had to dust off the cobwebs big time for myself to even